Chapter 14, Section 1, The Nature of Wave. First of all, what is wave? Wave is any disturbance that transmits energy through matter or empty space. So basically, energy can be carried away from the source by a wave. However, the material through which the wave travels does not move with the energy. For example, if you drop a rock in a pond, waves form the rock splash, carry energy away from the splash. But the water is still in the same place. It does not move, it does not transfer. The wave on the surface moves towards its sides, but the water only bob up and down. The fact that the water seems to move tells you that the waves are transferring energy. So like we said previously, most waves transfer energy by the vibration of particle in a medium. Medium is the substance that the wave travels through. All need a medium through which to travel. The medium could be air, water, or solid, like sound waves, water waves, seismic waves. However, we have other energy that does not require a medium. They can transfer through a medium or without a medium. For example, like visible light waves, microwaves, radio waves, and X-rays. They are examples of waves that can transfer energy without going through a medium. They are called electromagnetic waves. Electromagnetic waves do not need a medium, but they also can go through matter. We don't have any problem with that. Now, about the types of waves, we have so many waves, including transverse waves and longitudinal waves. Transverse waves are waves in which particles vibrate perpendicularly to the direction the wave is traveling. They are made of crests. A crest is a point on a wave with the maximum value of upward displacement within a cycle. And troughs. A trough is the opposite of a crest, so the minimum or the lowest point in a cycle. Water waves, waves of a drop, and electromagnetic waves are examples of transverse waves. Now, about longitudinal waves. There are waves in which the particles vibrate back and forth along the path that the wave moves. Waves on a spring are longitudinal waves. Longitudinal waves are made of compressions and rarefactions. A region where the coils are pressed together in a small amount of space is known as compression. So, compression is a point on a medium through which a longitudinal wave is traveling that has the maximum density. A region where the coils are spread apart, thus maximizing the distance between coils, is known as rarefaction. So, a rarefaction is a point on a medium through which a longitudinal wave is traveling that has the minimum density. Now, sound waves. They travel by compression and rarefaction of air particles, as shown in this picture. When the drum head moves out after being hit, a compression is created in the air particle. When the drum head moves back in, a rarefaction is created. So, what kind of wave is a sound wave? Comment your answer. Now, what do you think of when you hear the word wave? And write a short paragraph describing a time you might have experienced waves. That's it for today, guys. Make sure to answer the self-check questions and the section review as well. And do not forget to do your homework. Goodbye.